Okay, I'd like to discuss how meteor impacts affect coal deposits. The end of one geological period and the start of the next were caused in most cases by meteorite impacts. The largest of these impacts caused mass extinctions due to the change in the Earth's rotational speed and equator location. Coal deposits indicate where the equator was located during different geological periods. So you can see the mass extinctions that occurred were very abrupt, most likely caused by meteor impacts. So I would anticipate that all of these points were due to meteor impacts. The larger the point, the larger the impact. 300 million years ago, you had the Clearwater craters in Quebec, Canada. Typically, you would expect one large meteor impact to cause a hot spot somewhere on the opposite side of the planet. When you have more than one, destructive interference for the shock waves keeps it from converging, and therefore you typically wouldn't have a hot spot. 252 million years ago, the Wilkesland crater in Antarctica caused the Siberian traps. 200 million years ago, which I'm well aware nobody recognizes, it had meteor impacts in the Gulf of St. Lawrence, in Alabama, and in Mexico. No hotspot because you had 3 large meteor impacts, and again, destructive interference of the shock waves. And at 145 million years ago, the Moracoing crater in South Africa caused the Hawaiian Island hotspot. And 65 million years ago, you have the Yucatan Peninsula impact. But there's also another confirmed crater in Eagle Butte in Canada. A line drawn between Eagle Butte and the Yucatan impact shows it crosses the Little Rockies and Devil's Tower, and the large igneous province or hotspot at the time was Deacon Traps. From 360 million years ago to 300 million years ago, most of the continents were on one side of the Earth, making it heavier than the other. Therefore, it would have been tidally locked, providing 24 hours of sunlight a day. And plants growing with more sunlight allowed more coal to be deposited during this time, and also allowed oxygen levels to be higher than in any other time period. And here's a nice little chart of oxygen content during different geological periods. As you can see, during the Carboniferous, it had a lot more oxygen than at any other time. The only way that could have happened is by an increased production from plants. Since the land masses were not significantly larger during this time, plants would need to produce oxygen for longer each day, which they could do if they had 24 hours of sunlight. Another indication that the Earth wasn't spinning is the size of animals. While they were big for bugs, they certainly weren't huge in comparison to animals during the dinosaur periods or during current times. And there's something about, I saw a report indicating that more oxygen allowed bugs to be bigger. Probably had something to do with the chemical composition of their exoskeleton and being able to produce more material with more oxygen. And the black dots are coal during this time period, during the Carboniferous. Again, all the land masses were on one side, or mostly on one side. keeping the Earth from spinning. And here's some coal deposits in the U.S. during that time period. And then coal deposits in South America are inside the red square or rectangle. And here are coal deposits in Russia. I've added dates based on research of each of the basins. Kind of hard though when they indicate the coal was between 541 million years ago and 66 million years ago. But you kind of get an idea of when coal was forming in these specific areas. 360 to 320 million years ago in the Moscow Basin. 360 to 200 million years ago in whatever basin. So from 300 million years ago to 251 million years ago, two meteors struck in Quebec, Canada, changing the alignment of the poles by the angle of the impact and torque-induced precession. Clearwater East crater is 16 miles in diameter, while the Clearwater West crater is 22 miles in diameter. Both have been heavily eroded by ice sheets during ice ages. Coal formed around the South Pole in these different areas: South Africa, India, Australia, Antarctica. Here's a map showing some of the coal deposits from that time period, indicating that Antarctica had to be pointed towards the sun and basically rotating like this so that coal could form in these areas. We also have indication that the continents were together because of different fossils of the same types of animals all across this area before the continents broke apart. And during this time period, the animals were a little bit bigger, but certainly not the size of dinosaurs or even the larger animals that are alive today. A lot of ugly lizards. Okay, the rotational speed of the Earth increased slightly during this time period, but not enough to allow large animals to exist. Uranus is currently on its side, but the south pole of the Earth would have had to be pointed toward the sun for coal to accumulate in the areas indicated above. And this is Uranus, and while it's 180 out of alignment with the pole pointing towards the sun, it does seem to rotate, changing from the south pole pointing towards the sun to the north pole pointing towards the sun at different times. And here are coal deposits in Africa during that time period. We have Permian, Lower Permian, and the Upper Permian represented here in South Africa. And the blue shows coal deposits in South America during this time period. During Permian with the blue color. And then in Antarctica, we have coal deposits in Antarctica, which is currently covered by ice and snow up to a mile thick, and yet there was coal forming there. It couldn't have done it in the cold. And here we have the orange color showing the Permian, which is here. Then the Permian to Triassic, which is the purple here. We have more P's for Permian. And a crustacean. Cretaceous period. And here we have coal deposits in India. And here's the Permian with 1 through 9. Three and 4, 1, 8 and 7. You get the idea. India was close to Antarctica, and coal deposits were being formed during that time period. Here's the Australia area. I've added the times, or the time periods that I could get the Geological Department of Australia provided pretty good information on their coal deposits. So I was able to add some of the information showing that during the Permian they were making coal there as well. And coal fields of China. Here's late Permian. Late Carboniferous to early Permian are the whites, or cream color. Late Permian is the darker brown. And then we have Jurassic, showing a movement of the equator and the rain needed to form plants and then cause coal deposits to be formed. Meteor impacts on Earth cause the Earth to wobble, similar to displacing the tip of a spinning top. When the meteor impact hits in a direction opposite it to the spin of the planet, torque-induced precession forces the axis of the planet to shift. You can increase the speed of a ball spinning on your finger by adding momentum, but when you try to slow down the rotation of the ball tilts and falls off your finger. If you apply the front brake to a motorcycle moving forward, the front tire pulls to the right. If the motorcycle is moving backwards, like when you're going backwards down your driveway, you apply the front brake and it causes the front tire to pull towards the left. And this is also force-induced precession. And I have a little video. That's a video of my top. Here causes it to wobble. We have the interglacial period. And then when equilibrium sets back up, we have the next ice age. Okay. Explains about the wobbling of the Earth. Okay, this is a display of torque-induced precession. While it's spinning, you can add additional spin in the direction that the gyroscope is spinning. But if you apply force counter to the direction it's spinning, conservation of momentum forces it to twist over, and then you can add more spin in that direction, and this is what I believe happens when a meteor impact hits a planet. Conservation of momentum causes it to flip over, and this is what you have with Venus, which is upside down. This would be the amount of deflection that happened to Uranus when it was hit by a meteor impact. And this is similar to what happens with a basketball you're spinning on your finger. You can add rotation to it, but the minute you try to slow it down, it slips off your finger. Same is true with a motorcycle, the front wheel, when you apply the brake. It causes it to pull to the left. Pull to the right. And if you're traveling in the opposite direction, like rolling down a driveway, and you apply the brake, it pulls in the opposite direction to the left. And then, when there's no spin at all, this is what I believe happened during the Carboniferous period. The Earth was tidally locked to the sun, forcing sunlight to occur on the continents 24 hours a day, causing the largest amount of coal to be deposited during that time period and the highest concentration of oxygen during that time. Again, torque-induced precession. Meteor hits in the direction opposite to the spin of the planet, and it causes it to flip. Okay, and that was so professionally done. But what are you going to do? Alright, so we went across torque-induced precession. And I got that from Wikipedia. Okay, 251 million years ago, you had the Wilkesland meteor crater, or the Wilkesland meteor impact in Antarctica, forming the Siberian Traps. A hot spot nearly antipodal to the crater, which is here in Antarctica, which was another mass extinction. And 200 million years ago, 3 meteors hit North American continent, one at the Gulf of St. Lawrence, one near Gadsden, Alabama, and whatever this is pronounced in Mexico. Alright, the first large impact is in the Gulf of St. Lawrence. Seem to be having a little trouble with the color here. You can see it a little better there. But it would have hit somewhere here, causing this crater, caused this part of Canada to move from here. You can see we've got cracks here and here. And this curved part would have fit back here. And this island should be here and laying across this area, where we've got Prince Edward Island and Nova Scotia. And the geography of the Gulf of St. Lawrence closely matches the shape of the Chicxulub impact crater. At approximately 190 miles across, the Gulf of St. Lawrence crater is larger than the Chicxulub crater. There's a magnetic anomaly map showing the same type of shape as we see in the Gulf of St. Lawrence. You got an uplift here, a backsplash here, and a crack down through here. Very similar to the magnetic anomaly map of the Chicxulub crater. Okay, the second large impact was in Alabama, centered near Gadsden. And you can see the crater shape. The ring here goes into Mississippi at about 280 miles across. It would be one of the largest suspected meteor impact craters, and maybe why nobody was looking for it. That's a very large crater. And you can see the different geographic levels. Okay, this is what I think could be meteor impact glass found in Atala, Alabama, part of the NASA Rock Around the World project, where they use the same technology that they had on the Mars rover to analyze rocks. They indicate that this is metal or iron. But as you can see, it looks a lot more like glass with a coat of iron over it. It could have been, some iron-rich sandstone. See the bubbles and the burn and okay. This is the approximate location where it was found. Haven't been able to go to Alabama. Was hoping to go up this circular drive and look and see if I could find a layer of glass in the hillside or maybe other samples in this area. The state trooper's office is right across the street. But I called them and I couldn't get past the receptionist, of course, because I'm crazy. Like I said, it could be meteor impact glass from 200 million years ago. There are railroad tracks here. So if that was an old railroad system, it could be something out of an old steam locomotive boiler, or it could be out of a burn barrel. Without more information, it would be hard to actually say that it's meteor impact glass. And I also tried contacting colleges in the area, sent emails to several professors, and never heard anything back. And since I'm not rich and can't throw a ton of money at it, I really can't get anyone to take a look at it. Okay, and the impacts caused a slip fault. And this is the New Madrid catch point. See the earthquakes that have happened here. And this is the Mississippi embayment. Basically a gap between two plates. And this shows you the extent of the embayment. As this side has been moving up, it is pushed away from the Midwest side. The East Coast side is pushing up and creating this gap. The Gulf of Mexico would extend to Illinois if the embayment were not filled with sediment. Here's an earthquake map for North America, East Coast. And as you can see, there's a lot of earthquakes along this line, which I believe is the East Coast plate sliding against the Midwest plate. And where you have earthquakes, you have some kind of movement. If you don't have thrust building the mountains like this, then it has to be a slip fault where it's sliding against each other. And it's sliding against each other all the way up here. You have a bunch of cracks where it's compensating for this sliding movement. And as you can see, this would be the meteor crater edge. And these are the swarms of earthquakes near the New Madrid Fault. Okay, here's the Gulf of California, which is similar to what the Mississippi embayment would look like if it were not filled with sediment. Like I said, the water would be all the way up to Illinois from the Gulf of Mexico. And here are sinkholes dotted across Alabama, similar to the sinkholes around the Chicxulub impact, the cenotes. Here are the sinkholes around the cenotes and sinkholes around the Chicxulub impact. And we have a karst right in line with the edge of the meteor impact site in Alabama, basically indicating broken limestone. Third impact would have been down in Mexico, part of the dogleg somewhere here. As the largest of the three, this should be the largest impact crater, and without some kind of additional information, there's no way I can approximate the size. Need either magnetic anomaly or maybe on the ground testing to see where we have broken rocks and sphericals or any number of things. The pivot point between Mexico and the Yucatan Peninsula shows heavy seismic activity as it continues to move and open the Gulf of Mexico. There's all the earthquakes down at the dogleg between Mexico and the Yucatan Peninsula. And the fault line continues to grow in the Gulf of Mexico. Show the movement pushing towards the U.S. and towards the Yucatan, making it larger. And this is the Shoemaker-Levy impact on Jupiter, showing that multiple impacts are not that unusual. If you have a big meteor, chances are it's going to break up and then have several meteor impact strikes on a planet. Okay, Colorado Plateau. Impacts would have caused major destruction of nearby areas. Petrified forest covers a large area, of which the park is just a minor fraction. Something large had to cause this event. Okay, you can see the petrified forest here, and there are petrified trees all over this area. You can't buy them from the park, but there are plenty of other landowners who will sell you chunks of petrified logs for a price, of course. And some of the information on the geologic levels and the time periods. Some of the trees were dated to 211 million years ago. Others were dated 218 million years ago. Here we have 213 million years ago. But they all would have had to have occurred, or most likely occurred at the same time. Erosion of layers below the petrified trees could explain why they are dated later than 200 million years ago. You have erosion that takes away some of the soil, and it shows a later date when the trees were laid down, because it's an older layer that they are sitting on top of. Okay, meteor impacts cause fault lines, allowing the Mississippi embayment and the Gulf of Mexico to form. North America, South America, and Africa were connected prior to the three large meteor impacts. And you can see this is the Gulf of St. Lawrence, Alabama, Mexico. And then 195 million years ago, they hadn't moved apart that much. But at 150 million years ago, you can see that the Yucatan and the Gulf of Mexico has opened up. South America is starting to move away, Africa is moving away. Typically, the force from a large meteor impact will cause a volcanic hotspot on the opposite side, which I've said before, of the Earth through fluid hammer. Shockwaves traveling through the mantle bounce off the interior of the crust and around the core. When the shockwaves converge on a point, it causes a break in the crust, forming a hotspot. The location of the hotspot is determined by the angle of the meteor impact and force vectoring. When more than one large meteor impact occurs at the same time, destructive interference of multiple shockwaves prevent convergence, therefore minimizing the chance of hotspot formation. Alright, 200 million years ago. It's going to take a little more work to find the exact location of the equator. One of the most important things is right after the 3 large meteor impacts hit and spun the Earth a lot faster, that's when you have the largest dinosaurs. Truly tremendous dinosaurs, gargantuan in size. And the reason we didn't have bigger mammals during that time is with the higher rotational speed, it reduced the force of gravity, especially at the equator. The centrifugal force counteracted the force of gravity, therefore allowing bigger animals to live because they didn't weigh as much. It also reduced the partial pressure of oxygen, which meant that mammals would have a harder time breathing. See, these are the air sacs for dinosaurs, similar to the air sacs of birds. Here's a chart showing the altitudes that different birds can fly in very limited oxygen environments. So birds can breathe in thinner air and mammals cannot survive in the same locations. There we have 145 million years ago. The Meteor meteor struck Africa 145 million years ago and was the most likely cause of the Hawaiian Island hotspot. The impact would have been nearly antipodal to the Hawaiian Island hotspot. In other words, almost directly on the other side of the planet. And this is just showing the layout of the continents during that time. And the meteor impact would have been about here. And Hawaiian Islands somewhere over here. Chart showing the different ages of the land masses along the Hawaiian Island Emperor Seamount chain. And this is showing dates of up to 120 million years ago for the remnants that are hitting the Russian continent or continental plate. And this report indicates that Hawaiian Island hotspot could be from 100 to 140 million years ago. And that report puts the Hawaiian Island hotspot formation within the time frame of the Meteor impact. And from 145 million years ago to 65 million years ago, the green line indicates the probable location of the equator. I'm not sure whether the Earth was laying on its side, if the North Pole and South Pole were kind of like Venus currently. And coal deposit formed in Alaska, Canada, continental U.S., South America, Antarctica. The equator ran near the current positions of the North and South Pole. Here are coal deposits up in Canada, showing the different ages. and the megafauna that were alive in the shape of North America during the time period. All the dots are indicating fossil finds. Okay, some of the largest dinosaur fossils ever found are along the equator during this time period. Atomic and molecular bonds are limited in strength, and larger animals can only form from a reduction in gravity, since the Earth has not undergone large losses or accumulations in mass. A reduction in gravity could only be accomplished through an increase in the centrifugal force by increasing the rate of rotation. The largest increase in centrifugal force would be at the equator. The location of coal deposits from 145 to 65 million years ago indicate the equator, and fossils from the largest dinosaurs have been found along this line. Okay. Here we have during the Jurassic, when the largest dinosaurs were alive, and then here's where the Morquang impact occurred. Don't exactly know what happened 97.5 million years ago, but these are the animals that died out 65 million years ago. As you can see, during the Triassic, the animals were a lot smaller before the three large meteor impacts spun the Earth like a top. And here's some information in South America of large dinosaurs that have been found. At this website. Okay, the Chicxulub impact changed the alignment of the equator again. Meteor impacts not only make the Earth wobble like it is currently doing, but they also cause the poles to shift locations or change alignment. Torque-induced precession can flip a planet, as evidenced by Venus. Poles of Venus have flipped, causing its rotation to be opposite that of the other planets. And we're going through precession again, which we've already talked about. Chicxulub impact would have caused planetary precession due to the direction of the impact. Force vectoring determined from the offset between the Deccan traps and the Chicxulub antipodal points indicates the meteor hit the Earth at a 28-degree angle from horizontal. So here we have the antipodal point, or direct opposite point from the Yucatan impact. And this was done by Princeton. They laid out what they thought would be the alignment of the continents during that time, and where the antipodal points would be for the impact and for the Deccan traps. So the impact would have slowed down the rotation of the Earth and shifted pole locations, because it was traveling from this direction and hit at an angle of 28 degrees. Again, that's from force vectoring with the offset between the antipodal point and the actual traps point or impact point. The slowdown in rotation would have increased gravity, increased the partial pressure of oxygen, making conditions unlivable for larger animals, and provided a more favorable environment for mammals. Large meteor impacts send shockwaves through the mantle until they converge, producing a fluid hammer effect. Pressure forms a crack in the crust, producing a hot spot like the Hawaiian Islands, the Deccan traps, or the Siberian traps. Okay. And 65 million years ago, there were at least 4 meteor impacts. All these impacts traveled from current day east to west and hit the ground at an angle near 28 degrees above horizontal. The equator during this time was located just west of these impacts. Eagle Butte is a recognized impact structure up in Alberta. And the Little Rocky Mountains failed volcano causing uplift in the area from the impact. Devil's Tower, a failed volcano leaving the magma core, which did not erupt but solidified in an underground magma chamber. And the Chicxulub crater, right here in line. And as I indicate here, other impact sites are possible, and I think I may have seen a few from smaller impacts, but haven't had a chance to research them yet. And here we have the Wankel T-Rex, which is found in close to the Little Rockies. The Leonardo hadrosaur, it's indicated at 77 million years ago. That could be, again, from erosion and the fossil being laid on older ground. Dakota hadrosaur, which was a mummy, and the Leonardo was a mummy. That's dated at 67 million years ago. The Tanis fossil site, where they found a bunch of animals and directly related it to the Yucatan impact, dated at 66 million years ago. And then Sioux T-Rex at 67 million years ago, right here. Badlands National Park, where I believe we found meteor impact last. And then these are two hadrosaurs that were mummified in the lake formation between 69 and 66 million years ago. So we have suspected meteor impacts here and here, and mummified dinosaurs. One of the most complete T-Rexes, another nice T-Rex, the Tanis fossil site. There's a mummy, two more mummies here, and like I said, what I expect is meteor impact less. And there's the Leonardo site. Due to mummification, it retained original skin. Most complete dinosaur fossil ever discovered. It even has a mummified stomach containing magnolia, fern, and conifer vegetation. The Wankel T-Rex. Completeness and preservation of this specimen will allow new research. Dakota. Okay, and this one preserves much more than just impressions of the skin. The Tanis fossil site, where they found insects, bones, triceratops, marine microorganisms, snail-like marines, cephalopods, and all occurred during the time frame of the Chicxulub meteor impact and the Sioux T-Rex. And this is one of the hadrosaurs that were found in 1910. And this one was found in 1908. Again, two mummies. And this is the Laramide disturbance, which is an out-of-place fault line that occurred during the same time period as the meteor impacts. And they show the line here, much closer to the coast, which would be expected from the plates clashing and the uplifts as the ocean plate was subducted under the continental plate. And then at 65 million years ago, we have disturbance coming all the way out over here. And then 50 million years ago, it starts receding, and then 40 million years ago, not so much. Here's the Eagle Butte crater in Alberta. Not much information on the Little Rocky Mountains. They're an island on the northern Great Plains of Montana about 50 million years ago. 15-mile wide igneous dome pushed its way up through 17,000 million year old Precambrian basement rock to form this spectacular mountain range. Karst around the Black Hills indicates a large disturbance. Again, that's broken rock, broken limestone. And you can see it's pretty localized. It's a big bump. Okay, Devil's Tower is one of the many intrusive igneous bodies that comprise the northern Black Hill Eocene alkaline magnetic province. The Black Hills are the Laramide Arch that marks the furthest east extent of the Rocky Mountains. Laramide deformation began in the area about 64 million years ago and ceased about 40 million years ago. And again, 64 is real close to 65. And that location is in line between meteor impact in Alberta and the one in Mexico. Here's the Hells Creek and Lance Formation showing the erosion in areas where they found a lot of fossils. And this is the location where we found what I believe is meteor impact glass. About a mile west of the White River Visitor Center along Route 2. And this is a report of the rock found in the Badlands. There was a horizontal plate of glass in an eroded mound of dirt. In other words, there was a big mound of dirt sticking up and everything else around it was eroded away. It was on the north side of the road. We were parked in a bad location, so after we picked up the rock and looked at it a little bit, we moved further down the road and parked on the south side at a different eroded mound. A few hundred feet from the first mound, a layer of horizontal glass was again evident and extended the length of the mound. And we were on vacation and in a hurry, and I really didn't know what it was at the time. Knew it was something unique. So we sent it into NASA, the Rock Around the World project, and it was identified basically as glass, melted sand, whatever. And here's the evaluation like they did with the equipment from the Mars rover. Similar to the Mars rover, it wasn't actually from the Mars rover. And the chemical composition closely resembles impact glass from other known sites. Libyan glass, Owens Valley, California, obsidian, and Czech moldavites. This is a different sample that we picked up, and as you can see from the top, it has a bubbly appearance and very dark. It looks like glass. And the bottom has a rough texture like sandpaper, like the glass on top melted and then conformed to the sand texture below it. And I put an ad on Craigslist to have people go and take a picture of some of these rocks. Maybe a year and a half ago. And the area was closed because it's part of the Indian reservation, and because of COVID, they didn't want people traveling down Route 2. So this gentleman took pictures of glass on the picnic tables at the White River Visitor Center. I had a thin section made of the glass, and as you can see, they indicate it's mostly chalcedony. Here's some of the shots they took of it through a microscope. I don't know if that means anything to anyone. I find it interesting, and I've been told that it's most likely chalcedony, but you don't have a plate of glass that extends for hundreds of feet in a horizontal layer through different mounds. Okay, and this is where some of the interesting part comes in. Near coal fields in the U.S. Here are natural gas and oil sites which correlate to the coal locations. And another gas production in conventional fields. If you know where the equator was during the different time periods, it allows searching for coal, natural gas, and oil in specific locations at known geological depths. That's the end of my report. You're free to call me misinformed, questionable, or just stupid. I'm not crazy. My mother had me tested. Tell everyone you know about this article for whatever reason. They may be interested or just need a good laugh. Tell the butcher, the baker, the candlestick maker. Tell your third grade teacher or your hairdresser, but don't bother telling your wife. I already filled her in. Thanks for your time.